Welcome to the session. Greeting of the day. In today's class, we are going to see about a few PLC programming, PLC ladder programming. In such a way, it will be more helpful for the design of the mechatronic systems and it will be helpful for the future trends. So, from basic level, PLC programming, we have to see how far it will be helpful for our trends. So that we are going to see. Devise a timing circuit that will switch on an output for 1000 seconds and then switch off. Normally by the device, by the software, each timer will work up to 999 seconds only for T1. And above that, by the conditions, by the software, we have to use a second timer. And the second timer will work up to 999 seconds only. So what I want to do, they have given the condition of 1000 seconds. Software, the timer, the simulations can be done up to 999 only. But it is 1000. The 1 second we have to give the second timer. For 1 second we should use the timer 2. So we will see. Input has been given from the power rail. Power is ready. Input has been given and output has been received. And output is gives this input to the second run. And the timer of 99 seconds is running. Because after 1000 seconds it should terminate. That is our program. Therefore timer 1 has been given. After this timer 999 seconds, it gives the input as a T1 and it will activate the second timer 1 second. After 1 second what happens? After 1 second this will give the brake contact at the top. You see, here we have given the T2, but I have made a brake contact there. Therefore, when it receives the signal, it is going to brake. Therefore, already the supply which went there is going to brake now. So when the signal is received, it brakes now. Therefore, what happens? If it is braking, we won't get the signal here. So it converted. The signal is received, it is converted as an open contact. The brake contact has been converted as open because we are pressed there. Because it is sensed. Now there is no contact. What happens if there is no contact? The supply is not there. Therefore, motor is not on. So motor is not on. As it is, it will become terminated. So likewise, we can use the timer as one of the options for controlling systems of the mechatronic system. Now I want to do a device, a timing circuit that will switch on an output after 20 seconds for 1 second, then off. It means when the circuit is switched on, after 20 seconds of time only, the output should come. But output should come for 1 second and then it should again terminate. Again it should go for 20 seconds. So that is our program. We will see. You see? See? Input has been given after 20 seconds of time. After 20 seconds of time, this T1 is connected here. If the T1 is activated, we can able to see it is here. I have a disconnection there, and then it goes to here and activate the output. When the output is activated for 1 second only, it should run. Therefore, this 1 second, if it is activated here, the timer 2 has been given for 1 second. After the 1 second, this brake contact going to brake. This brake contact is going to brake here. If it is braked here, what happens? You see, if the brake contact has been braked, the circuit is not passed. The circuit is not passed here. The circuit is not passed. Therefore, the power supply which are available, which are connected here, which are power is coming here, it is not crossing. Therefore, it is going to terminate. So, power output should on after 20 seconds, but it should off immediately after 1 second. So that is how some few programs we can able to do. Here, I want to show other process. Device a system in the PLC. When start push button is pressed, I am just doing a push button here. It is started. How we have to do, or giving a diagram, as given by the diagram you see, I have taken a 2-cylinder actions in such a way. In the pneumatic, we are operating like this. When the solenoid is pressed here, as the solenoid is pressed, the inlet goes to here and it should move. Inlet goes in here and it moves to the other direction. Now, there are two conditions. One is kept here to sensor B minus, it is sensing this initial position, and as the air inlet is there or hydraulic inlet is there, it keeps on moving and it is going to touch here. In such a way, B plus sensor will give the input. So B minus, B plus for cylinder B. Similarly, for A cylinder, the air should come here and it should move. The initial position is sensed as A minus, and this movemented, this position is mentioned as A plus for the A cylinder. Okay. Accordingly, for this we have, for forward direction we have A plus solenoid. For the reverse direction we have A minus solenoid electrical connections. For here we have B plus electrical connection to move the cylinder forward, and B minus electrical solenoid to move the cylinder backward. So, what is the sequence of going front and back? I have attached two combination I want to take care. 2 cylinders I have taken. In such a way, one I want to operate first A position I want to operate. It means A position I am operating. This I want to operate first. If this is operated, if A1 is operated, the air from here it moves to this direction. When this is operated, air should go and the piston moves from the left to right. Now, A cylinder having at the right end. Next I want to operate B plus. Where is B plus? This one. When this electrical is activated, air goes through inside and it moves the cylinder at the right. So both cylinders came to the right end. Now again, I am returning back. A minus I am giving. It means this solenoid to be activated. In such a way, it can give a supply in the backward direction, so it can move backward. And similarly, when the B minus, next one, I want to activate the B minus. Similarly, when it is activated, it can able to move in the backward direction. This combination we should do now. You see, first I have started. Here. When it is started, at initial condition, because you see, we have operated B minus at last. It means when it is operated B minus, this is going to come here and it is a last condition. As per the design, A plus forward, B plus forward, A minus return, B minus return. Then this is the last condition. It means the last sensor which is detected in the last cycle is B minus. Likewise we understand. Therefore, I am giving here, when the B minus is in this condition, when the B minus is there, when the B minus is detected, we consider this all at the 0th condition. Therefore, I have taken B minus there. Now, started, the power is going here and it is waiting here. Now, it means at the 0th condition, B minus also will detect, B minus sensor will also detect. Now it is detected. Both are detected at the same time. Now A plus is activated. What is A plus? A plus is here. This solenoid is activated. Therefore, when this solenoid is activated, what happens? This piston on the cylinder of A will move from left to the right. If it is moved from left to right, what happens? It is going to detect the A plus. From here it is started and it is going to detect this. This has been touched now. This sensor has been touched. This position sensor has been touched. It gives the input to the A plus. Now, the connection from the power rail here is already running. Power is ready now. Power is ready, and it should come here. It is ready here. It is ready here. When all these are activated, outputs are going to activate. Now A plus activates the A plus sensor. This sensor. After this, what is my condition? A plus activated. Next B plus should be activated. Therefore, I am giving this connection to the B plus. What happens? If the B plus solenoid is activated, it moves the forward direction of the cylinder B from left to right, and it detects the B plus there. It touches the B plus. B plus sensor will be sensed as such a way the piston moves from left to right and reaches that point, B plus point. Now the B plus point is detected. Therefore, the connection from the power rail is going to go here. It is going and it reaches the A minus. And what is my condition here? A plus, B plus, next A minus. Therefore, that I am giving the A minus here. If the A minus is detected, what happens? A minus is belong to cylinder 1. Cylinder A. On the cylinder A, in the backward return formula this is. So A minus solenoid is activated. Therefore, the power goes, the pneumatic air goes to this left direction and push the piston backward. When the piston is coming backward, this point of piston is going to return to the position of A minus. Position of this A minus is going to return, and it will be sensed by the A minus. See, after A minus capital A minus is activated, solenoid is activated. The solenoid is operating the piston to come back, and after the coming back to the original position of A minus is detected. When A minus is detected, we have done this one, we have done this one, we have done this one. When A minus is detected, this connection has to be connected to the next position of B minus. Therefore, I am giving this A minus sensor activation to the B minus in such a, now the cylinder A is over. It went forward, it came back. This push is over. The only pending is B forward has been done, B return has to be done. Therefore, the B minus to be done, this one to be done. So I am connecting the B minus there, output. When the A minus is activated, it is going to connect to the B minus, and then the return also will be possible. So at last this is end run. So likewise, we can able to operate a multiple cylinders through a PLC diagram. So likewise, we can able to do that. So that is what I have written. A plus A minus are the limit switches of cylinders to detect. B plus B minus are the limit switches for cylinders B. Cylinder A contains A and A minus. B contains B minus and B plus. Capital A plus and B plus are the extension of the cylinders. Extension of the cylinders. A minus and B minus are the return of the cylinder A and B. On the same connection, I want to do some other A plus, B plus, A minus, B minus. It should be cyclic. When we are saying this word cyclic, we should keep remember to come over for this latching process. Come over for this latching process. So that is how we can able to do these things. A start, and when we need, we can go for the stop button. Purposefully I am keeping the stop button as a brake contact to off contact to make when the stop is sensed or pushed, brake will happen. Now have connected a internal relay, and the internal relay has been again making a latching, and then it is going to connect there. This all other diagrams are as usual for the previous one, because A plus B plus A minus B minus, A plus B plus A minus B minus. It should be cyclic. I have added a latching treatment. See, internal relay has been connected here. Here really we have a start and B minus. Here we have a internal relay and B minus. And as usual A plus B plus A minus. As usual here A plus B plus A minus B minus. A plus B plus A minus B minus. It is a cyclic process. First, for a cycle I have included the latching treatment here. The same diagram. This is what we have understood. The same diagram I have incorporated here also. I have drawn the diagram A plus B plus, but not A minus B minus. I have changed the operation of B minus and A minus. What we have to do then? I have to connect first A plus, B plus has been done. Then in the outputs, I have operated the B minus and then the A minus. The sequence I have changed. Here you see, we have A plus B plus A minus B minus. A plus B plus A minus B minus. This sequence is okay. From that sequence, I want to connect these various sensors. See this A minus, this 4 has been connected in the little bit according to our requirement. First I want to connect this A minus to A plus, then the A plus to B plus, but I am connecting this B plus to the B minus first. B minus, I am doing this B minus. After the B minus I want to connect to this, last I am connected to the A minus. So somewhat I am arranging themselves according to my requirement, according to the sequence what I have willing to do. So likewise the cylinder can be operated sequentially. Now we will keep moving towards the next one. Here the timer we have mentioned, T1 can operate up to 999 seconds only, and then we can take the one more timer which can able to operate up to another 999 seconds. Accordingly, if they have given 1000, we have taken here 2 timers. So that's how the programs are we can able to do. So this is about after 20 seconds it should on. Likewise we have C. I am coming to the next one. I devise a ladder diagram that can be used to, what I want to do, start a motor. First point, a start button will be there. So start button will be there. Start button will be there. Okay. So after that, after delay of 100 seconds, after delay of 100 seconds, start the pump. I want to pump start after 100 seconds when the start button is clicked. After starting of the motor, when the motor is switched off, there should be a delay of 10 seconds before the pump is switched off. We understand easily, you see, when an input has been given, it should switch on the motor. After on the motor for after 100 seconds of time, pump should on. Now I am terminating this motor. Off. When the motor is off, after the 10 seconds of time, pump should terminate. This is our program. Motor on, 100 seconds, pump on. It can run. Running duration not given. But when the motor is off, pump should off after 10 seconds of the motor switched off. So that is our condition. So we will go ahead and see here. You see, first I have started. Here I want to stop the motors physically. That is why I have given the condition here. That is a brake contact I given that will come. So started, the motor has been running now. Motor has been running now. And this is start is a push button. Therefore I am doing the latching also. I have done the latching also. So it means this has been connected and it is going, keep on running. Motors keep on running. After the motor is on, according to the 100 seconds, the pump should on. Therefore, this motor's output I have taken here. Here the power line. The power is ready. The power is ready. Power is ready, and when all the inputs are given, the power can go to the output. So here in the started, the power is going here. The power is going. And this output of motor has been given here. And therefore, this motor gives the input of timer of 100 seconds. After 100 seconds, we should on the pump. After the 100 seconds, the T1, that is named as T1, given the input here. This input has been given to the pump there. We should terminate the pump after 10 seconds. That is why I have taken as T2 here, that we should come again. Therefore, the connection goes there, and it is connected, and the pump is now on. First cycle or first cycle is completed. Now what I have to do? Motor should off when I am interested. If the motor is off, after 10 seconds, pump should off. Now, I am giving this pump in the latching also. So motor is continuously running latching, pump is continuously running. But the on-in system of 100 seconds is given. Now I want to terminate the motor and I want to terminate this pump also. What I have did here? Now, when the stop button is clicked here, physically, as of my interest, at any time, I am pressing here. The power supply goes up to 10 seconds. Simultaneously, we have created the brake contact here already. Therefore, what happens? This brake contact is going to disconnect this supply to the motor. Therefore, it is not going to operate. Motor is stopped now. My interest here, the motor is stopped. Now, what happens? This point is become a disconnected point. Is open. The brake contact has been opened now. So there is no such a contact. So the motor is not on. It is contact is break here. But here this stop activated this T2 of 10 seconds. Now the pump should off after 10 seconds. Now the pump is 10 seconds running. We are waiting for 10 seconds. Now the pump should off. Where I connected this one? I have connected this pump. You see, I have connected this timer. Before the timer, as a brake contact, it's already in the program. This has been interconnected there. Now what happens after 10 seconds? After 10 seconds, it is going to disconnect. After 10 seconds, it is going to disconnect. If it is disconnected, there is no contact. You see, there is no contact between these two. It will be disconnected. It is disconnected here. Then automatically the power from the power rail is not going to pump. Therefore, all those things are terminated. Pump is up and pump is going to terminate. Motor is terminated after 10 seconds. Pump is terminated through off timer. I have used here. Off timer in the terms of brake contact. On timer in terms of create contact. So we have to play with that. So I have used brake contact 2 here. One is here. This when it is on, it is going to reverse action takes place here. And simultaneously, this timer also I have connected through this 2. So somehow we can able to play with this. The summary. In today's class regarding the PLC systems, we have seen about the contacts, about the ladder program, about the contacts, and about the brake contact, and about the relay coil, and about the timer, about the counters. So these things we have some with respect to advanced mechatronics approaches we have seen. The remaining part of the subjects we'll see you in the next session. Thank you.